This video is about the cumulative distribution function. It's normally written with a capital F, and it's defined to be the probability that x is less than x0. So capital F of x0 is the probability that x is less than x0. So for example, f of 2 is the probability that x is less than 2. F of 3 is the probability that x is less than or equal to 3. Now, during the course of this video, I'm going to use x0 as the input to the cumulative distribution function, and that's to distinguish it from the x that is used when we're thinking about the probabilities. Now, here we have a probability density function, and the equation of the line is given by f of x. That's lowercase f. So that's showing the equation of the line. So the equation of this line is given by lowercase f of x. But this area here, because it's going up to 3, is given by capital F of 3. So that area is given by f of 3. And to calculate areas, we need to use integration. So it's equal to the integral from minus infinity up to 3 of f of x dx. Of course, it's not always 3, it's just 3 in this case, so the general way of writing this is if the input is x of x naught, so it's the integral from minus infinity to x naught of f of x dx. So x naught is the limit at this point here, and the equation of the line, the bit we're integrating, is f of x, so that's why we're integrating that. So you can see it's important to distinguish between the x here, which is the variable for this function, and the x here, which is this limit in this case, so that's why we've got this x naught business. And just finally, to reiterate what we've been talking about, this expression here gives us the area here, which is the probability that x is less than or equal to 3. And again, to emphasize, this diagram here shows the probability that x is less than or equal to whatever that value there is. X naught is the letter that we normally use. So here's an example. We've got a cumulative distribution function. Notice that it's got a capital F of x here, and we need to calculate some probabilities. Now the graph looks a little bit like this, and we need to find the probability that x is between 2 and 3. So if we draw 2 in and 3, and what we need to do is to calculate the whole of that red area, and then we need to take away this blue area here. So the probability that x is less than 3 is equal to f of 3. The probability that x is less than or equal to, less than 2 is f of 2. So f of 3, we just put 3 into this expression here. So that's 3 squared is 9, 9 sixes is 54, 3 cubed is 27, 54 minus 27 is 27, so that's 27 over 32. F of 2, we need to put 2 into that expression. So 2 squared is 4, 4 sixes is 24, 24 minus 2 cubed, that's 8, that's 16, 16 over 32 is a half. So the probability that x is between 2 and 3 is 27 over 32 minus a half, which is 11 over 32. Now here we've got another example, and in this case the equation that we're given is small f of x. So we're given the equation of the line, and we need to find the cumulative distribution function, the CDF. So from the PDF to the CDF, we're going to need to work out some areas. Now the graph looks a little bit like this. This point here is 2. So we're going to need to work out two equations, one for this part of the line, one for this part of the line. So firstly, we need to find out f of x naught, where x naught is between 0 and 2. That's simply this area here. So that area there is going to be a half of the base times the height. To work out the area of a triangle, we need half of the base times the height. So the base is x naught. The height, I can get the height from this part of the equation. When x is between 0 and 2, the height of the small f of x is a quarter of the x value here. So it's a quarter of x naught. So that height there is here, quarter of x naught. So we get 1/8 x naught squared. Secondly, we need to find out this area here. And the simplest way of doing that is to do 1 minus the green area there. So in this case, we need to do 1 minus this triangle, the area of this triangle. So the base there is 4 minus x naught. That point here is 4. You can see that from here. So the area of this triangle is half of the base times the height. So it's a half of the base. Now the base length is 4 minus x naught. And then it's multiplied by the height. Now the height I can get from here. It's a quarter of 4 minus whatever the x value is. So it's a quarter of 4 minus x naught. So that's 1 minus half times a quarter is an eighth, 4 minus x naught all squared. So in case it's not entirely clear, this part here is when x is between 0 and 2, sorry, when x naught is between 0 and 2, and this part is when x naught is between 2 and 4. So let's put this all together on the next slide. So we've got f of x naught. Well, if x naught is negative, then there's no probability. If x naught is between 0 and 2, it's 1/8 of x naught squared. That's what we got on the last screen. When x naught is between 2 and 4, it's 1 minus 1/8 of 4 minus x naught all squared. And then once we go over 4, the cumulative probability has got to be 1. So these bits here were the bits that we worked out. These were the hard bits. These bits are easily forgotten, but are important. You need to write it out. You need to write out those bits. Don't just assume those parts. They're very easy, but you always need to write those parts in. Okay, now here we've got another question, similar to the last question, in that we're given f of x, small f of x, and we've got to work out capital F of x naught. So we're given the equation of the line. We've got to work out the CDF, the cumulative distribution function. But this time, because this is non-linear, there's an x squared and there's going to be an x squared there, we can't just use areas of triangles because we've got curved lines. So we're going to need to do some integration. It's probably going to help to see what the graph looks like, and that's what it looks like. So to start off with, we're going to need to work out the expression for that area there. So it's going to be an integration from 0 2x naught of 1/8 x squared dx. And that works out to be, if we integrate 1/8 x squared, that's 1/24 x cubed. That's between 0 and x naught. So we slot that in and we get 1/24 x naught cubed minus naught, which is obviously that. So this expression that we've got here is the answer for f of x naught when naught is less than x is less than 2. Now we need to do the same for the second part, so we'll go on to another slide. So we need to work out an expression for the whole of this area here. So we need to split this into two sections. The red section here is simply going to be capital F of 2. And the remaining section, this blue section here, we're going to get from integration. So for this part of the graph, f of x naught is going to be f of 2, that's the red part, plus the integral from 2 to x naught of 1/8 x 4 minus x dx. So we're integrating small f of x. Now, why is this capital F of 2? Because capital F tells us the cumulative probability, the area up to that point. So we need to go back to the expression that we had before, which was 1/24 x naught cubed, and put that in there. So on the previous slide we saw that if we put in 1/24 of whatever that input number is there, that's going to tell us the cumulative probability. Now we've got to integrate 2 to x naught, and then I think we need to multiply out the expression. So it's 4/8 x minus 1/8 x squared dx. And we need to continue on the next slide. So 1/24 of 2 cubed, that's 1/3. And then 4/8 is a half, so we've now got this expression. So we've got 1/3, and then we need to integrate a half x, which I reckon is a quarter x squared. We've got to integrate 1/8 x squared, so that's probably 1/24 x cubed, from 2 to x naught. That's a 3 there. There we go. So that's 1/3, and then we put in x naught. Then we subtract 2, so we put 2 into here, 2 squared is 4, 4 over 4 is 1. We've got a double negative coming up here, we're taking away, and we've got a minus sign here, that's a plus. Put 2 into here, 2 cubed is 8, 8/24 are 1/3. So we've got 1/3 minus 1 plus a third, so that's altogether that's going to be minus a third. And we've got 1/4 x naught squared minus 1/24 x naught cubed. So the original question asked us to work out what f of x naught was, and as before, at the lower end it's 0, the probability of x naught being less than 2 is 0. Between 0 and 2 it's 1/24 x naught cubed. Between 2 and 4 it's yes, it's this expression that we just had, and then when x naught is bigger than 4 it's 1. So it's a little bit of a nuisance to have to go back to getting everything together, but obviously it's the neat solution, so get into the habit of writing out the full answer like that. Don't expect people to find all this working within your previous answers. So this is the final answer to what f of x naught is. Now, final example, what we've got at this point is the capital F of x expression, and we want to find the small f of x. So we're given the cumulative distribution function, we need to find the probability density function. So what we've seen before is to go from the probability density function to the cumulative distribution function. We integrate, but obviously to go the other way around, the inverse is going to be to differentiate. So that's what we need to do here. So if we differentiate naught, then that's clearly naught. If we differentiate 1/24 x cubed, that's 1/8 x squared. If we differentiate 6/24 x squared, that's half x. Differentiate 1/24 x cubed, that's minus 1/8 x squared. And differentiate 8 is 0, and differentiate 1, that's also 0. So we've got this, and this naught is otherwise. Now I've made a bit of a mess of this, because this whole section here is normally written underneath at that point. So my apologies for that, it doesn't make any sense to write otherwise at the start, otherwise is at the end. So your answer should have that down at the bottom. And that's this video completed.